Hello there, this is Ms. Nakayama, and today's lesson is 11.3, Limits and Continuity. So in this video, we are going to cover determining whether a function is continuous at a number, and then we're going to determine what numbers a function is discontinuous. So easy, pretty much easy to do it from a graph, but now we're coming at it from an algebraic perspective. So there are three conditions that are needed to determine if a function is continuous at a certain number. The first one is that function defined at that value? Number two, does the limit exist? And number three, are those two things equal to each other? So here is what an example looks like. Determine whether the following function is continuous at 1. So we are concerned about x when x is equal to 1. So the first part of that was, is it defined at f of 1? So we're going to go and plug in 1. I didn't mean to do that, but anyway, plug in 1 everywhere you see x. So 1 minus 2 is negative 1 on the top, and 1 minus 4 is negative 3 on the bottom. So we find that f of 1 equals 1/3. Now I need to go determine the limit of that function as x approaches 1. So I'm going to plug in 1 for x and plug in 1 for x again, which is what I just did there. So that limit is 1/3. Okay. And now the third condition is, are 1 and 2 equal to each other? Does the value of the function equal the limit of the function? And the answer is yes. So we say the function is continuous at 1. All right. Now, next, we have to find out where functions are discontinuous. Really easy thing to remember is that any polynomial function, okay, if you can recognize a polynomial function, is continuous at every number. But all the other functions we've talked about, rational, exponential, logarithmic, sine, cosine, tangent, secant, cosecant, they are only continuous in their respective domains. But if you know it's a polynomial, then it's continuous everywhere, and that's the answer. But let's look at this. This is a piecewise function. F of x equals 2x if x is less than 0, x squared plus 1 if x is between 0 and 2, and 7 minus x is that if x is greater than 2. Now, all of these functions, y'all, those are all polynomials. That means they're continuous everywhere. However, they are part of a piecewise function. And because they are part of a piecewise function, I need to look at each of these endpoints. So I'm going to go plug in whatever it says for x into each function. So in that first one, if I plug in x equals 0, 2 times 0 is 0. All right, so that means that I have the point 0, 0 on the graph at that point. All right, now in the middle one, I got to put two numbers. I got to plug in x equal to 0, and I have to plug in x equal to 2. So if I plug in x equal to 0, 0 plus 1 is 1. If I plug in 2, then 2 squared is 4, and 4 plus 1 is 5. And now I'm going to the bottom function. X is greater than 2, and I'm going to go plug in 2. And when I plug in 2, 7 minus 2 is 5. So to determine if there are any points where the function is discontinuous, I look where the x values are the same, and I've color-coded it here. So in this particular case, these 2 points are not the same. They're different. So that means it's not continuous. It's discontinuous at that point. These 2 values are the same. So it is continuous at 2, but it is discontinuous at 0. So that's all you got to do is just go plug in the endpoints, which is what I tell you to do when we had to graph it. All right, last example. Another one, f of x equals x squared minus 400 over x minus 20 if x doesn't equal 20. And if x does equal 20, then the value of the function is 40. So again, I only have 2 cases, so I got to plug in 20 each time. Okay, well, when I plug in 20 in the bottom, there's no x, so that means it's 40. That's my constant function. But on the top, if I plug in 20, on the bottom, I get 0. So that means I need to factor it. So if I factor the top, that's the difference of 2 squares. That's going to be x minus 20, x plus 20, and the bottom is still x minus 20. So I have a common factor on the top and the bottom, leaving me with just x plus 20 on the top. And when I plug in 20 for x, I get 40. So I have the same point, and that means that this function is continuous everywhere. So pretty straightforward. If you have any questions, please don't hesitate to email me or come see me. Thank you so much for watching, and y'all have a great day.